Hi class. I wanted to do a quick little demo here that I think is a little bit of fun. Don't know if any of you guys have seen one of these things before, but they're called a Jacob's ladder. They're called a Jacob's ladder. This particular version has 6 steel balls. They're actually pretty heavy when I hold them up. And what you can do with these is, right, if you watch, if I pull one back and let it fall, you notice that it shoots one out the other side. So why pull one back? And each time a marble comes back, it kicks one out the other side. Now this one's getting a little bit old, so it starts to get funky after a while. So I have a question for you. What do you think is going to happen if we pull 2 of these back? I'll pause just for a second for you to think about that. Well, hopefully you gave the answer, or the answer occurred to you, that it would look like this. Notice that when I pull 2 back and let them fly in, they kick 2 out the other side. Okay. Well, now there are 6 of them here, so hopefully it makes enough sense then. Let's pull 3 back. What do you think is going to happen? Of course, it's going to kick 3 out the other side. Now we're going to get a little bit harder. What do you think is going to happen if we pull 4 of them back? How many people think that 2 of them, the other 2 will go shooting out? How many people think it'll be 3 shooting out? How many think it'll be 4 or 5 or 6? Again, if we pull back 4 and it hits, it's going to kick 4 out on the other side. Well, to figure all this out, it's a little bit counterintuitive, but there are 2 things I want you to be thinking about here, and we'll talk about this later on in the school year in physics. There's 2 conservations that are happening here. The first is conservation of momentum. Now we pull this marble back. When it hits, it's got a certain amount of momentum. That momentum has to be conserved, so it's going to kick something out with the same amount of momentum on the other side. Now, what's not obvious is why doesn't this marble come down and kick the other 5 out, but because they're 5 times as much massive, maybe they only go 1/5 as fast, so their momentum is conserved, momentum being mass times velocity. Well, if we did that, yeah, our momentum might be conserved doing that, but here's the catch. Our energy is not conserved doing that, our energy. So this kind of reaction, or most physical interactions, we need to conserve both momentum and energy. And this is an elastic reaction. I should be careful about that. In elastic collisions, we need to conserve both. That's why however many you see I pull back, that's what's going to shoot out the other side. All right. So we'll talk about that more later on in the year, but I just wanted to give you something fun to look at and think about. Maybe you've seen one of these before. If you haven't, then maybe you can find them in a novelty store. They are kind of fun and entertaining. All right, guys, we'll see you tomorrow. Take care. Bye.